Alright, hello everybody. Welcome back to trigonometry. So today I want to go over two interesting problems that are under the same category of trigonometry. And they're part of just solving trigonometric equations. So the key in them is to put them in the form sine and cosine rather than secant and tangent and uglies. So the first one I'm going to go through. The second one I want you to try, and then we'll go through it together. So the first one is, what angles theta satisfy the secant of theta times the tangent of theta equals negative 2/3. You might want to plug in values, you might want to do something, you might, I don't know, do some things, you might put one in the form of the other, but what I'd do is I'd say that this is just sine, or sorry, this is just 1 over the cosine of theta times the tangent, which is the sine of theta over cosine of theta, which is equal to negative 2/3. So now what we can do is we can say that that's equal to the sine of theta over the cosine squared of theta, right? And that's equal to negative 2/3. We see the cosine squared of theta, and what I think of is the sine squared of theta, the Pythagorean identity for trigonometry, I guess. Sine squared of theta plus cosine squared of theta equals 1 for any angle theta. So that means that the cosine squared of theta is equal to 1 minus the sine squared of theta. So we have this here. We have sine of theta over 1 minus sine squared of theta equals negative 2/3. That means that negative 2 plus sine squared of theta equals 3 sine of theta. That means that we can have sine squared of theta minus 3 sine theta minus 2 equals 0. Now notice that this is a quadratic. We have something squared minus 3 times something minus 2. So if you don't see it, we can substitute x for sine of theta, right? Let's say sine of theta equals x, and we're going to get x squared minus 3x minus 2 equals 0. But I'll keep it in this form. So now the variable is sine of theta, and we just need to solve this. So we can factor it, or we can use quadratic formula. I'd rather factor it. So I mean, quadrum is usually better, but sine of theta, I don't want to mess up, so I'm gonna just factor it. Yeah, so two numbers that multiply to negative 2, add to negative 3, seems like the old days. Negative 2, and, sorry, wait, what? Can't think. Okay, multiply the negative 2, what multiplies to negative 2 and adds to negative 3? What? I can't really do this. Oh wait, no, this is 2 sine squared of theta, right? Yeah, we multiply by, oh, sorry about that, there's 2. Yeah, now it makes sense. Okay, multiply to negative 4, add to negative 3. That seems like negative 3 and, no. What am I doing? Negative 4 and 1. Yeah, sorry. So now what we do is put this middle one up. We get 2 sine squared of theta, negative 4, so not minus 4 sine of theta, plus sine of theta. You might think, why are we splitting it up? That's because there's 3 terms. So if we make it 4 terms, we can group it into 2 and then 2. So these 2 and minus 2, and then these 2. That's equal to 0. So now what we can do is we look on the left pair. We factor out 2 sines of theta, and we're gonna get 2 sine of theta times sine of theta minus 2. Plus, here we can just factor out 1, I guess, and we're going to get 1 times sine of theta minus 2. Now what we can do, equal to 0, we can factor the sine of theta minus 2, and we're going to get 2 sine of theta plus 1 times the sine of theta minus 2 equals 0. That means that sine of theta equals 2, or sine of theta equals negative 1/2. Hopefully you've noticed this by now, but the range of sine of theta is just 0, is just negative 1 to 1. Because when you graph it, it goes ooh, and it keeps, and this is the max point. These are all the minimums, where this is 1 and this is negative 1. So it'll never go above to something unless you have unless you've done some transformations, which we haven't. So that means that it can never be equal to 2. So we can remove that. So sine of theta equals negative 1/2. We know sine of 30 degrees, or sine of pi over 6 equals 1/2. So sine of negative pi over 6 equals, that. So theta is equal to negative pi over 6. Is that it, though? No. We also know that the sine of pi minus theta is equal to sine of theta. So sine of pi minus this, or pi plus pi over 6. So we're going to have 7 pi over 6. Excuse me. So yeah. Sorry. These are the two. But we can also say that negative pi over 6 is equal to we can say it's at 5 pi over 6, but I'd rather put it as 11 pi over 6. So that means, but we can also add we can add we can add any multiple. Yeah, you can add any multiple of 2 pi if that is like positive or negative. So we could say that that's equal to we're putting it as 11 pi over 6 by adding 2 pi to it. Right? Yeah. So 11 pi over 6 plus 2k pi and 7 pi over 6 plus 2k pi. Where k is an integer. So k is integer. Okay, cool beans. So this is the answer. So what we did was we just made it into a quadratic by using the Pythag for this. Factored it, looked at the domain and range, and yeah, that was not the hardest thing, hopefully. So now you have an idea of how to do it. So I'd like you to try one of your own. So sorry. The next one I want you to try is I want you to try to solve which one? I'll make you try this one. So yeah, 8. Oops, that's an S. I know how to draw my 8s. So what we're gonna have is we're gonna have 8 tangent of theta is equal to 3 times the cosine of theta. Try it on your own. I mean, like, literally, please try it. I don't want you to just watch me do nothing. Okay. I find these problems interesting for some reason. So put it in terms of sine and cosine. So we're gonna. Why is it just zooming? I'm not even doing anything. Okay. I'm like moving it, but it keeps moving back. Okay. Hold on. Shut up. Okay. Plug in sine and cosine. We're gonna get 8 sine of theta over cosine theta equals 3 cosine theta. Multiply by cosine theta on both sides. We get 8 sine of theta equals 3 cosine squared of theta. Again, cosine squared of theta is 1 minus sine squared of theta. We're gonna get 8 sine of theta equals 3 minus 3 sine squared theta. Add 3 sine squared theta minus 3 on both sides. We're gonna get 3 sine squared of theta plus 8 sine of theta minus 3 equals 0. What two numbers multiply the negative 9 and add to 8? That would be 9 and negative 1. So we can split it up. We're going to get 3 sine squared of theta plus 9. What's happening? Plus 9 sine of theta minus sine of theta. My sloppy handwriting and this dumb computer and dumb thing are working together on this one. Minus 3 equals 0. Factor, we're going to get 3 sine of theta times sine of theta plus 3 minus the sine of theta plus 3. Factor out sine of theta plus 3, we're going to get 3 sine of theta minus 1 times the sine of theta plus 3 equals 0. That means that, oops, what the heck? The sine of theta equals negative 3 and the sine of theta equals 1/3. This is impossible. If the sine of theta, oh wait, sorry, the question here was find the sine of theta. So yeah, it's 1/3. Sorry about that. You can also say that is equal to the arc sine of 1/3, but I'd rather not know that. It's not one of the nice ones that we know. So yeah. Yeah. Sorry, I didn't read the problem fully. It was saying find sine of theta. Sorry about that. Yeah. Yeah, so that's it. I got these books from AOPS, or I got these problems from AOPS. And yeah, thanks for watching and check AOPS out. I just found these interesting and how you can use a range to eliminate one option and how you can use a quadratic. So yeah, thanks for watching. See you guys next time. Goodbye.